Hello and welcome back to the straight line section of the SQA Higher Maths course. We are looking at medians, altitudes and perpendicular bisectors. We're going to do an example with two of these and finding the point where they cross. Okay, it's a standard exam question. So I'm going to jump down to page 15, I think. So before we do the actual question, a quick reminder from National 5. If we are finding out where two lines cross, so where does the line 3y equals x plus 15 and the line y equals x minus 3, where do those two lines intersect, or where do they cross? We can do that using simultaneous equations. So set them up, call them 1 and 2. Please name them. Call them 1 and 2. Don't just leave that part blank. And then say what we're doing on the next line. So here we're doing 1 subtract 2, so 3y minus y equals 2y. X minus x is 0, which is why we're subtracting. If I'd done 1 plus 2 there, I would not eliminate the x terms. Okay, so we're trying to eliminate either x or y. So say what we're doing, so equation 1 minus equation 2, and 15 subtract minus 3 is 18, so 2y equals 18, y is 9. And then go back to either equation 1 or equation 2 and substitute 9 in to calculate the value of x. So those lines intersect at the point 12, 9. So I will let you guys read through other methods we can use for solving simultaneous equations. But for straight line, I would suggest that elimination, which is the way that you do the majority of your National 5 simultaneous equations, is the most efficient method. So let's just have a quick look at a similar example to that. So we have, actually, you guys pause the video and have a go yourselves. Okay, so hopefully you've had a go. So I'll go through the two possible ways you may have done it. So 2x minus y plus 11 equals 0. So I've just rewritten it as 2x minus y equals negative 11. X plus 2y equals 7. So equation 1 and equation 2. So I have decided to double the top equation to give me equation 2 and equation 3 here. So I have x plus 2y equals 7. 4x minus 2y equals negative 22. How do I eliminate these y terms? Well, if I subtract them, I will get 2y minus 2y, which would be 4y, so I will not eliminate the y terms if I subtract there. So I'm going to do equation 2 plus equation 3. So 2y plus minus 2y is 0y, so that eliminates the y terms. X plus 4x is 5x. 7 plus negative 22 is negative 15. So 5x equals negative 15, x equals negative 3. So I have the x coordinate of negative 3. So substitute that back into equation 1. So 2 lots of negative 3 subtract y equals negative 11. Negative 6 minus y equals negative 11. Add 6 to both sides and we get y equals 5. Of course we need to write the actual coordinate for the point of intersection, so that point would be negative 3, 5. Now if we chose to double equation 2 instead, which we could do here, so x plus 2y equals 7 becomes 2x plus 4y equals 14, that would still work. So I've just rewritten equation 1 underneath equation 3 there. So here I need to eliminate the x terms, so I've got 2x and 2x in both equations. So I'll need to subtract this time because 2x minus 2x equals 0. So I'm going to do equation 3 subtract equation 1. 4y minus y becomes 5y. 14 subtract negative 11 becomes 25, so y equals 5. Substitute back into equation 1. Rearrange and x equals negative 3. So in the same way that we did using the method on the left hand side there, we get exactly the same answer, so that should cover whichever way you've chosen to do it. Right, so that was a quick reminder about how trying to find the point of intersection of two lines. We also know how to find a median, altitude and perpendicular bisector, so let's try and bring it all together. So triangle PQR has vertices PQ and R. I would like you guys to pause the video and have a go at part A yourself. Okay, so hopefully you've done part A. Find the equation of altitude QS. So we need to find the equation of this straight line. So what do we know? We don't know the point S. It looks as though it's the midpoint, but it's not necessarily the midpoint. But we definitely know it is at right angles to the line RP, so I'd find the gradient of RP, which substituting in using y2 minus y1 equals x2 minus x1 comes out as 1. So the gradient of QS, which is perpendicular to that, would be negative 1. And we know the point Q, so then substituting in, remember A is the x coordinate, B is the y coordinate, we should end up with y equals x plus 5, or we may write that as y minus x equals 5. The reason why I've chosen to do that is that I've read the questions and I know I'm going to have to use simultaneous equations in point C, but if you've written y equals x plus 5, that is totally okay at this point. Right, I'd like you also to have a go at part B now. So again, pause the video and have a go. Okay guys, so hopefully you've had a go at that. So finding the equation of the median, so that is the line going from R to the middle of the opposite side. So I'll need to find the midpoint of PQ, and then I'll need to find the gradient of the line RT once I've found out that the coordinate of point T there, which is the midpoint of PQ. So the midpoint of PQ is 7/2, 9/2. Again, just looking halfway in between each value. If you're not too keen on that because it's a fractional value, you can write it as a decimal if you really want to, but would do like a fraction at higher rather than a decimal. And then find the gradient of the line RT. So again, we're just substituting in y2 minus y1 over x2 minus x1. I would change this 3 to 6/2. I would change a 2 to 4/2 because we're subtracting and then we're going to be dividing a fraction. So we end up with 15/2 over 3/2. So we could invert this fraction and multiply by 2/3. Or I might be thinking, well, I'm dividing here, so that means how many lots of 3/2 do I need to make 15/2? Well, I just need 5 lots of 3/2 to make 15/2. So just using our knowledge of division, that would just come out as 5. And then substituting into y minus b equals m bracket x minus a. So remember, we have the point T, we have the point R, we have the gradient of this line. So we could use T or R. Either one would be fine, we would come out with the same. So I've gone for the point 2, -3. So substitute in, expand the bracket, tidy up, and we get y equals 5x minus 13, or we could write that as y minus 5x equals negative 13. Okay, now guys, I'd like you to pause the video again and have a go at part C. Okay, so hopefully you've had a go and you have a value for m here. So we have two straight lines and they cross at point M, so we're just finding out the value of m. So as I said before, in part A, I've written my answer as y minus x equals 5. In part B, y minus 5x equals negative 13. Okay, so the nice thing about this question is we have the same coefficient of y, we have the same amount of y terms already. They're both positive, so I'm going to subtract them because y minus y is 0. So equation 1 subtract equation 2, so x minus 5x is 6x. 5 minus negative 13 here is 18, so 6x equals 18, x equals 3, so the x coordinate's 3. If I substitute that into equation 1, we can, oh, where am I going? There it is. Substitute into equation 1, y is obviously 2, because 2 plus 3 equals 5. So the point M is 3, 2.